Okay, so we're going to talk about solving systems of equations. Two different types. We're going to talk about solving equations with two variables and two equations, and also solving a system that has three variables with three equations. And here's what they'll look like. If you have a system of two linear equations in two variables, we'll call that x and y. We get ax plus by equals c. Second equation would be dx plus ey equals f. And it could be that the coefficients are the same. A and D could be the same, but they don't have to be. Then we've got a system of three linear equations in three variables, and for that we'll use x, y, and z. And we've got the three equations, as you can see here, ax plus by plus cz equals d, and so on. So we've got three different equations and the three variables x, y, and z. How do we solve them? Well, there are actually two different processes that we use to solve systems of equations. Normally, there's two different processes. The first one is called the substitution method, where we substitute one variable for another expression. You'll see that as we go through it. The second process is called the elimination method, or some books call it the linear combination method. And that's where we eliminate a variable as well. Actually, in both cases, what we're doing is eliminating a variable. That gives us an equation or equations that we can solve easily. And that's the whole point of this. We want to eliminate a variable that allows us to solve the system. So let's do an example of two equations with two variables using the substitution method. So we've got 3x minus y equals 13, 2x plus 2y equals negative 10. One of the things that leads itself to using the substitution method is when you've got one of the variables that has a coefficient of either 1 or negative 1. When you've got that case, then substitution is easier to use. We could solve the first one, for example, by solving it for x. But then when you divide both sides by 3, you're going to get fractions. Now, you all should know how to handle fractions, but why make it harder when you don't have to, which is why we look for 1 and negative 1. On the other hand, we could also do it in the second equation, because if you solved it for either x or y, when you divided both sides by 2, you wouldn't have a fraction. So that would work, but it's just easier if one of the coefficients is 1 or negative 1, like this. So what we're going to do is take the first equation, 3x minus y equals 13, and then we're going to solve it for y. So the first thing I did was add y to both sides, okay? And then I was solving it for y, I subtracted 13 from both sides, and I got y equals 3x minus 13. Now what we're going to do is substitute that expression for y in the second equation. It's got to be in the second equation because we got that substitution from the first equation, so you don't reuse it. We go to the second equation. So 2x plus 2y equals negative 10. Notice we take the y and replace it with 3x minus 13, and that's what we have here. Notice we have only variable x. Y is gone. We eliminated it, and that was the point, which means we now have a simple linear equation to solve, and that's what we're going to do. First step is to distribute the 2. So that gives us 2x plus 6x, 2 times 3x, minus 26 equals negative 10. Then I combine like terms, giving me 8x minus 26 equals negative 10. And then I add 26 to both sides, and I get 8x equals 16, or x equals 2. And that is the first part of our solution. Remember, our solution is going to be a point, an x and a y value. We have the x. Now let's find y. And to do that, we can take that 2, that x equals, substitute it in either of the two equations, either one. Why? Because we used the first equation to find y and the second equation to find the value for x. So we can plug it in, take your pick. I picked the first one, 3x minus y equals 13, and I plugged in 2 for x, giving me 3 times 2 minus y equals 13, or 6 minus y equals 13, or negative y equals 7. Don't forget the negative. It's easy to do that. And then multiply both sides by negative 1, and you get y equals negative 7, giving me the solution to the system, the point to negative 7. Now, I want to mention this. If you want to check your answer, one of the things you can do is take that substitution x equals 2 and plug it into the second equation. When you plug it into the second equation, you must get the same y value. And if you do get that same y value, then you know you got the right answer. Okay? If you got a different answer, then you made a mistake. Somewhere along the line, there's a mistake. Okay? So that's a really good way to check, and it's an easy way to check your answer. Okay, now let's do a system of two equations and two variables, but we'll use the elimination method. In the elimination method, what we're going to do is eliminate one of the variables, but you'll notice they have completely different coefficients. So what we're going to do is strive to find coefficients where they are opposite for either the x value or the y value, which means we're going to have to multiply each of these two equations by some number to get opposite coefficients. We could have picked x or y. I picked y. No good reason I picked y. We could have just as easily have picked x. So what we're going to do is figure out what the least common multiple is of 5 and 4. That would be 20. And we're going to multiply the first equation by 4 to give us negative 20y. And we're going to multiply the second equation by 5 to give us positive 20y. And you'll see when we do that, what that gives us. So here we go. Here's the system. Multiply the first equation by 4, the second equation by 5. What that gives us is coefficients of the y value that are opposite, negative 20y, positive 20y. When I add these two equations together, the y goes away, and that's what we wanted. We will have eliminated that variable. I just want to go really quickly through this. Make sure you multiply all terms by the 4. So it's 4 times 9, 4 times negative 5, and 4 times negative 7. That's where I got this expression from, this equation from. And then I multiply the second equation by 5. So it's 5 times negative 6, 5 times 4, 5 times 2, giving me these two equations. When I add them together, 36x minus 30x is 6x. Negative 20y plus 20y is 0y. That was the goal. We eliminated the y. And negative 28 plus 10 is negative 18. And then we solve it for x to get x equals negative 3. Okay? Then we do the same thing that we did in the substitution method. We plug negative 3 in for x in either of the original equations. This is where it's important to mention, make sure you use the original equations, because if you use one of these, but you made a mistake when you were multiplying, then you won't catch your mistake. You'll think it's the right answer. And that's not, you don't want to do that. That's not a mistake you want to make. So I'm going to take x equals negative 3 and plug it into the first equation to give me 9 times negative 3 minus 5y equals negative 7. Negative 27 minus 5y equals negative 7. Add 27 to both sides, I get negative 5y equals 20. And then when I solve it for y by dividing both sides by negative 5, I get y equals negative 4, giving me the solution to the system of negative 3, negative 4. Again, you can check your answer by taking x equals negative 3 and plugging it into the second equation. When you do that and solve it for y, you must get negative 4, otherwise there's a mistake somewhere along the line. But in this case, I'm pretty sure we didn't make a mistake, so we're good. Now, let's look at